One of the things we do when we study functions is we tend to group them, just like when we study numbers in general. We'll group numbers into even numbers, odd numbers, prime numbers, that sort of thing. We do functions like that too. So let's look and see what it means for a function to be even. And I'll show you the graph of an even function here, first of all. Now, let's just make an observation here. Notice that if I come over here and evaluate this function at 1, and I find f of 1, notice how it has exactly the same value if I come over here to negative 1. See? At negative 1, we have the same value. F of negative 1 and f of 1 is the same. Now, we could do that for 2 as well. F of 2, notice it has the same y value as f of negative 2. And in general, it's not just 1 and negative 1, 2 and negative 2, but any x we come to on here. If we find that f of x is exactly the same as f of negative x, then we say that function is even. Okay, let's look at another one. Here's another example of an even function. Now notice we've got g of 1/2, okay, g of 1/2 right here equals g of negative 1/2. Notice, same y value. Okay, g of 3/2 equals negative g of 3/2. Same thing, see? And finally, g of x is equal to g of negative x. So once again, we notice this, see? Okay, so we say these two functions are even because this happens, not because we find examples like this one, f of 2 equals f of negative 2. No, but for every value of x, every f of x equals f of negative x. Now, let's look over here. Here's another one, okay? And notice h of 1 equals h of negative 1. See? You can look here on the graph. H of 2 equals h of negative 2. And finally, h of x equals h of negative x. And another way to say this is we have symmetry with respect to the y-axis. In other words, for each one of these graphs, notice if I were to fold these graphs along the y-axis, this right-hand side would lay perfectly on top of the left-hand side. There's symmetry there. Symmetry with respect to the y-axis. Now let's look at another classification of functions, odd functions. And here's an example of an odd function. Now notice, if I were to evaluate this function at, let's say, negative 2/5 right here, okay? Here's negative 2/5. Notice I get exactly the opposite that I would get if I evaluate the function at positive 2/5. See, over here at 2/5, I go up a little, and over here at negative 2/5, I go down a little, the same amount. Okay, now let's look at another value. Let's look at negative 1. F of negative 1 is here, and that's exactly opposite of f of 1. See, f of 1 is here, f of negative 1 is here. These are opposite, right? This is 1, this is negative 1. And in general, for this whole function here, we could go through and we would find that f of negative x is equal to the opposite of f of x. In other words, evaluating at the value f of negative 1 is going to be equal to the opposite of f of 1. And that's going to be true for every value on this function. Okay? Plugging in a positive value of x will give you exactly the opposite of plugging in the negative value of that same x. Okay? Now, another thing to note about these particular functions, these odd functions, is notice if I spin this function around 180 degrees, just pivot it on its origin, look what happens. Notice how this function looks. And then if I pivot it, it looks the same. In other words, if I spin this function around on its origin, I can't tell the difference. It looks exactly the same. That's a property of these odd functions. Now let's look at another odd function. Okay, we'll call this one g of x. Now notice if we look at g of negative 1/2, I guess that'd be right here. I get this value. Then if I go over to g of negative 1/2, I get the same length here, the same distance from the x-axis to the curve, but it's the opposite direction. See? So g of negative 1/2 equals to negative g of 1/2. I could do the same thing for 1. Here I got g of negative 1. I go up here, g of 1, down by the same amount, only the opposite direction. And in general, g of negative x equals negative g of x. That would be true for all of these values. When that happens, we have an odd function. And notice, I'll spin this one around. Notice how it looks. And then if I rotate it, spinning on the origin, I get the same graph. It looks the same. Okay, let's try h of x over here. Same thing. Notice g of negative 1 and g of 1, same thing. Okay, g of negative 2, g of 2. They're just opposites, right? We get the same situation, opposite values. H of negative x equals negative h of x in general. Okay, so, and notice if I spin this one around, see, looks the same. So, h of negative 1 equals the opposite of h of 1, h of negative 2, the opposite of h of 2, and in general, h of negative x equals negative h of x. And we say that odd functions have the property that they have symmetry with respect to the origin. In other words, if we spin them around like I did here with each one of these 3 graphs, you can't tell the difference. Okay, they look the same. Now, let's see what is required if we encounter a function. What's required of us in order to determine if it's even, odd, or neither? So let's remember a couple of things here. To determine if a function is even, we're going to compare the original function, the f of x, with what happens when we replace the x's with negative x. If those two are the same, then we have an even function. Now, to determine if a function is odd, we compare f of negative x, replacing all the x's with a negative x, and seeing if that's the same as taking the opposite of the function. So let's look at an example. Let's consider this function. F of x equals x to the 4th plus 2x squared plus 3. Now, I'm going to find f of negative x. In other words, wherever I have an x, I'm going to put a negative x. See? Right there and right there. Now notice that this negative x is raised to an even power. That's going to mean that these turn back to positive, okay? So if we evaluate this, we get x to the 4th plus 2x squared minus 3. Now that is exactly the same as the original function. So this is an even function. Now, let's look at this, g of x. Now, I need to compare f of negative x with the opposite, not f, but g of negative x with the opposite of g of x. Well, let's find negative g of x first. I'm just going to put a negative outside the function, distribute the negative through, and here's what I get. This is negative g of x right here. That's what that is. Now, let's find g of negative x. Well, I replace all the x's with a negative x, as I've done here. Now, negative x to the 5th power, that's still going to be negative. Negative x to the 3rd power, that's still negative, and this is what we get. Look at these. They're the same. So g is an odd function. Now, if neither one of these situations hold, if we find that f of x is not equal to f of negative x and negative f of x is not equal to f of negative x, if neither of those conditions hold, then we say that it's neither even nor odd.